Okay, for the next part of the problem, we're now going to go through and expand that e to the 3it using Euler's formula. So far we've got an e to the negative t, and then that e to the 3it becomes the cosine of 3t plus I times the sine of 3t. And again, this is times the vector negative I and 1. We now need to multiply this into this vector, and so we'll distribute. So that's e to the negative t cosine 3t times a negative I, and then plus an e to the negative t times I sine of 3t times negative I. And then for the second row, it's going to be e to the negative t cosine 3t times 1 plus e to the negative t times I sine of 3t times 1. All right, and now we'll use the properties of I to simplify this down. And so in the first one, we're going to have a negative I e to the negative t cosine of 3t. And in the next one, we're going to have a negative I squared. So that becomes a plus 1 e to the negative t sine of 3t. And then for the lower one, stays the same because they're multiplying by 1. That's e to the negative t cosine of 3t plus I times e to the negative t sine of 3t. All right, and again, that's just one single vector. So the next thing we have to do is now break up this vector into two parts. And we're going to break it into the real parts and the imaginary parts. And that will give us two separate vectors. So we're going to have, for the real part of this, an e to the negative t sine of 3t. And then we'll have an e to the negative t cosine of 3t. And then for the imaginary part, we'll factor out the I, and we will have a negative e to the negative t cosine 3t, and we will have an e to the negative t sine of 3t. So you'll notice here that we actually have two different vectors, and these two vectors are linearly independent. You could go ahead and prove that using the Wronskian. And since we are solving a 2x2 system, and we need to have two independent vectors, we actually have both vectors that we need to get a general solution to our problem. So there's no need to take the conjugate and get two more vectors, because we don't want four vectors to a problem that needs just two for its solution. And in fact, if you do find those other two vectors, they're just a linear combination of these two original vectors here. And again, we just need to get the two. So now we're going to go through and take these two vectors and express our solution.